Hello everyone, myself Devi Parvathi, working as Assistant Professor in Marri Reddy Institute of Technology and Management. Today I am going to discuss about Introduction to Machine Learning in Machine Learning subject. Nowadays we are all using machine learning techniques and artificial intelligence in all the applications. Mostly we all hear about that machine learning and artificial intelligence. Then this artificial intelligence also working based on this machine learning. So first we will see what is machine learning. The term machine learning was first introduced by Arthur Samuel in 1959. So this machine learning was first introduced by that Arthur Samuel in 1959. The machine learning definition is it is a branch of artificial intelligence where computers making decision without being explicitly programmed. So actually, in that programming languages, we are giving the instructions, we are giving the rules. Based on that instructions, the programs will be work and gives that output. But in this machine learning, computers making decision, it takes own decision without being explicitly programmed. And that means explicitly means without being explicitly means by users. Without being rules or instructions by users. Without being explicitly programmed means without giving rules or instructions by users, and it will be making their own decision. Computers making their own decision. So that is called machine learning. So here, deep learning is the subset of machine learning. So deep learning is a subset of machine learning that filters data through the multiple layers. Deep learning working as like a human brain. Like human brain, deep learning is working. It is a subset of machine learning. So machine learning is a subset of artificial intelligence that uses statistical learning algorithms that learn patterns in data over time. So it can be learns that patterns. So the machine learning is learns that patterns and it contains that machine learning algorithms. And artificial intelligence is enables machines to think without any human intervention. So we want to use that artificial intelligence when we work based on that machine learning and deep learning. And machine learning can be based on the deep learning. That means first deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. So we want to learn that artificial intelligence. We know about the deep learning and machine learning. We want to learn that machine learning. Then just we are idea about that deep learning. So here deep learning working as a human brain, and machine learning without human interaction. Then based on the algorithms it can be work. And artificial intelligence can be combined both, combine both deep learning and machine learning. So it can be think like humans and same working with machine learning algorithms. So this is that machine learning. Let us see what is the difference between that traditional programming and machine learning programming. So in traditional programming like C, C++, Java, like that, all the programming languages, we are giving the input. In traditional programming, we are giving the input data. Data can be input. Then here write the program. That means rules and regulations, rules are instructions. We are giving the rules in that program. Then using the traditional programming, we are getting that output. For example, say we are giving that data. Input data is 2 and 2, and we are giving that operations, arithmetical operation. We are giving that arithmetic operation 2 plus 2. Then that is that instruction. Then that output will be giving that output. The traditional programming gives the output 4. That means it can be, for example, calculator also. So in that calculator already arithmetical operations, that means arithmetical formulas are already installed, predefined, and we are giving that input. Then it can be based on that instructions and based on that arithmetic operations. Then it gives that output. That is that traditional programming. Coming to the machine learning, the data can be given as the input, then and gives that expected output also. Then using these machine learning algorithms and prepares that patterns and when prepares that rules, and it gives that program. That means it gives that patterns and it gives that rules. It can be only prepare that, it can be stores that patterns and rules. So that is that. Here gives the data as a input and output, and it gives that program. For example, see, we are all using that Flipkart, Amazon, etc. So nowadays we are all using these apps, Flipkart or Amazon, anything. So and we want to buy any product, or we want to order that any product. Then first we are searching for that product. Yes, in that Amazon or in Flipkart app, then we are searching that product. And next time, if you are using same app, or if you are opening that app, then it shows that some products related to the previous search. That means we are giving that input and output. That means then now expected output. And based on that input and output, and it gives that instruction. That means it gives that related. It gives that instructions to the users. So that is that machine learning. That means some searches, what are the previous searches related to the previous searches. Then related items can be displayed on that screen. Then we are again we can search. And like that, that means we can train that. We can train that machines. Machine learning means we can train that. The humans can train that machines without being explicitly programmed. So that is that machine learning. That is the difference between the traditional programming and machine learning programming. Next, see this. How machine learning can be work. First train the data. That means based on that more examples or more data, then train the data. That means train that data to that machine. Then train that machine learning algorithm based on these using this trained data. Then machine learning algorithm. Train that machine learning algorithm. You can train that machine learning algorithm. Then machine learning algorithm can be maintain that relationship between that input data and output data, expected data. Output data and input data, it can be maintained that relationship between that input and output. Then it can be creates that model. Here it can be creates that model. That means here it can be stores that patterns and rules. It can be stores that patterns and rules and creates that model input data. Then now we are giving that new input data. That means new input data you can be added. So then using this machine learning algorithm, using this model, using this new data, then it can be predicts whether the data is correct or not. Then if it is correct, then it can be model will be successful. Otherwise, again train the algorithm and train that machine learning. Train the machine learning algorithm. Again it can be repeat this process and again creates that model, and based on that new data can be arrived. Then based on that new data, and it can be gives that prediction. That prediction is correct, then it can be a successful model. Otherwise, it can be again repeat that process. That means retrain that algorithm. Again retrain that algorithm. So for example, see that spam detection. For example, spam detection model. So in that one, first giving that number of thousands of mails, spam mails and unspam mails. Thousands of mails, spam mails and unspam mails, and it can be gives that to the system, gives to the computer or system, and it can be trained the data. Then based on the data, then it can be creates that spam detection algorithm. Using that spam detection algorithm, and it creates that model input data. It can be creates that model input data. Then new mail arrays. And new mail arrays using this model input data and using this spam detection algorithm, then it can be predicts whether it is that spam mail or unspammed mail. So if it is that spam mail, then it can be okay, successful model. Okay, if it is not spam mail, that means if the prediction is wrong, then it can be again retrain that machine learning algorithm. Then we retrain that algorithm, again repeat this process. So this is that how in this way the machine learning can be work. Now let us see what are the advantages of that machine learning. The first advantage is automation. So automation means it can be reduces the need of manual programming. That means manual programming, human work, manual work can be reduced. That machine can be do humans work. So manual programming is reduced. So manpower can be reduced. Next, second one, continuous improvement. So learns and improves with more data. It can be trained more times. Again, repeatedly. Then it can be improve this process and improves with more data. Next, high accuracy. Can make better predictions than humans in many cases. In some cases, it can be make better predictions compared to the humans. So that's why high accuracy is there. Next one, handles complex data. So works well with the big and complex data sets. That means human cannot be handled some of the times. So humans cannot be handled that big data sets, big databases. So that's why within this machine learning can be handles that complex data, big database and big data sets. So that's why it can be works well with a big data sets. So next one, saves time. So speed up decision making process. In this machine learning, speed of decision making process is there. So that's why it can be saves the time compared to the humans. So humans can be take this work, then it can be takes more time. So that's why same work can be assigned to the machine learning, then it can be completed fast. So that's why saves that time. So next one, pattern recognition. So in this machine learning, pattern recognition is there. So that's why it detects that patterns that humans may miss. If that humans are if some cases humans are missed that patterns, then that also that machine learning algorithm can be recognize these patterns. So next one, real time processing. So it can be analyze and predict instantly. So fraud detections like that, some of them and spam detections and fraud detections are it can be analyzed and predict instantly. Next one, reduces human errors. So the machine learning can be reduces the human errors, that can be the decisions or data driven, not biased. So it can be reduces that human errors, that humans are making that errors, then it can be reduces by using these machine learning algorithms. Next, coming to the disadvantages. So here also disadvantages also there. So first one is data requirement. So in this machine learning, we are using based on the data only. Machine learning algorithms work based on the data. So that's why need large number of quality data is there. So that's why data requirement is more. So that is the one of the disadvantages of that machine learning. Next, high cost. So development and computation are very expensive. So develop that machine learning algorithms and computations are very expensive. So that's why high cost is there. And next, third one, time consuming. So training models takes a lot of time. First, we should train that machine. So that is it. Lots of time. It takes lots of time. After training that machine, so it will be predicted so fastly. But we should train that machines. It will be take more time. So that's why time consuming also there. Next one, overfitting risk. So model may performs well on training data but fail on a new data. So some of the times model maybe performs that trained data, but if that new data is erased, then some of the times that is also fail. So these are disadvantages. Next disadvantage is security issues also there. So it can be vulnerable to cyber attacks. Next, maintain. maintenance. So needs regular updates and retraining. So if the prediction is failed, then you can retrain that model, again retrain that model. So more times you can retrain that model. So that's why maintenance is more. Next, bias in data. If the data is biased, the results will also be biased. So if data also biased, then results also be biased. So that's why that is also one of the disadvantages of machine learning. Now, coming to the applications of that machine learning. So this is that these are the applications in that machine learning. So in that travel in healthcare and marketing field, sales field, social media field, automation field, and credit and insurance field. So these are all fields we are using these machine learning and machine learning algorithms. So see one by one. So first application is virtual personal assistants, like a Google Assistant, Amazon Alexa, Microsoft Cortana. These are the virtual personal assistants. So in these virtual personal assistants, we are using these machine learning algorithms. And next one, traffic prediction. For traffic prediction, Google Maps, Bing Maps, Maps.me, like that. In that Google Maps, Google Maps can be trained by that machine learning algorithms. So that's why we are all of them using Google Maps. So for the traffic prediction, in that Google Maps traffic prediction, if the traffic prediction is there, then it can be sourced in that red line like that. So that's why in there we are using this machine learning. Based on that machine learning, and it can be predicts the traffic and it can be shows to that users. Next, social media personalization. So product recommendation for the next time. So already I told you. Then Flipkart and Amazon, we are search for that any product. Then it can be next time we are opening that same app. Then it can be sourced that recommended. It can be recommended to that products previously searched. What are the related to the previously searched products? Then it can be sourced that recommended to the related products. So that is that one of the application of that machine learning. Next, email spam filtering. Spam filtering, spam detection algorithm. Using that spam detection algorithm, emails can be filtered spam or unspam. Next one, online fraud detection, and it can be identify the theft, fake accounts, man in that middle attacks. So based in the, using these machine learning algorithms, we can be identify the theft, make accounts or fake accounts, and man in that middle attacks. Online fraud detection also one of the application of that machine learning. Next, stock marketing. In stock marketing also we are using these machine learning algorithms. Next, assistive medical technology. In medicals also disease identification and anything in that medical field also we are using these machine learning algorithms. Next one, automatic translation. Language translation. We are translating the language from English to Hindi, Hindi to English, English to Telugu, like that. We are using the translation apps also. So those are all apps can be based on that, they're developed by based on that machine learning and machine learning algorithms. So these are the applications we are used in this based on machine learning. So next one, well-posed learning problems. So how the machine learning algorithms are developed. First, well-posed learning problems. What are the learning problems are there? How we can be learned. How the machine can be learned. So first, well-posed learning problems. A computer program is said to be learned from the experience E with respect to sum of tasks T and performance measure P. So a computer program said to be learned. How it can be learned? How it can be learned means from experience E. Experience is considered as E and sum of the respect to the sum of the task T. What are the tasks we are giving? That is represented as T. And what are the performance? What are the performance? The task. Performance of the task that can be measured by P. And what are the learning experience from the task? That is E. So its performance task T measured by P improves with experience E. So we are giving that some task T, then that performing the task, that performance can be measured by P, and experience. So whenever we are performing the task, we are getting that experience. Yes, same like that. Some machine also, same machines performs the task, and performing the performance of the task and getting some experience. Yeah. So getting some experience. So that is that learning problem. Well posed learning problem. So in this one, some examples we will see that some examples. So first example is checkers learning problem. In that checkers learning problem, so task is that playing checkers game. So that is that same like as as a chess. So checkers board is there. So playing that checkers, that is the task. The task is T. Task T is checkers, playing checkers. What is that performance? It can be win percentage of games won by against opponent. So the what is the performance measure? How you can be performance measure means percentage of games won against the opponents. How many games are won that against to the opponents? Then that is that percentage can be the measure by measure, that is P. So next, training experience. How we are calculating the training experience means playing practice games against itself. So first of all we are playing practice games against itself. Then it can be won by that. It can be useful for that won by that against opponents. So we are improving our performance. Then we can be training that experience. Then we are improving our performance. That means that's the same like as machine also. Machine wants to perform some task, then it can be takes the training experience, then it can be performance is more. So that is that one of that example checkers learning problem. So next example is handwriting recognition learning problem. So handwriting recognition learning problem. So how you can be trying that machine for this handwriting recognition learning problem. First of all, giving the task is, what is the task is recognizing and classifying the handwritten words within images. So we are giving that images and words, and the machine can be recognizing and classifying that handwritten words within that images. So what is that performance measure? How we are measure that performance is percentage of words correctly classified. How the machine can be correctly classified that words, then the performance is more. Okay, otherwise the performance is less. Next, training experience is a database of handwritten words with given classification. The training experience is database of handwritten words with given classification. So we are giving that database of handwritten words in that with the giving classification. So based on this given classification, then it can be recognize and classifying handwritten words within images. So that is that handwritten recognition learning problem. So next example is robot driving learning problem. So in this robot driving learning problem, the task is driving on public 4-lane highways using vision sensors. So driving on public 4-lane highways using vision sensors. So you based on that vision sensors, then it can be drives that public 4-lane highways. How we can be measure that performance? Average distance traveled before an error. So we are training that machine. We are giving that some rules and regulations like that. So then it travels before an error. Okay, without error, it can be travel average distance. So that then it can be that performance can be more. Next, training experience. Training experience is a sequence of images and setting commands recorded. Giving that sequence of images and setting commands recorded, giving that commands means instructions. Then based on this, then that average distance travel before an error. This can be it can be traveled that average distance, then the performance is more. Otherwise, the performance is less. So these are the examples of that well coached learning problems. So based same like as we are trying that machines are giving the task, and then it can be we train that machines based on the training experience, then the performance can be measured. So the performance is more okay. Okay, it is that well, it is that well. Otherwise, it can be train that algorithm. Okay, thank you.